I want to tell you a story. It's a science fiction story I read many years ago, and I wish I could remember it better, but here's the gist of it. In this science fiction story, some mysterious people just suddenly showed up somewhere. There was a group of these people, and they were a little bit different than humans. They were human, obviously human, but there was something really odd about them. And people got to wondering, well, where did these people come from? And they finally admitted that they were not from here. They're not from here, and but they refused to answer questions about their background. Anyway, they were very smart people, very extremely knowledgeable. Earthlings learned a lot from them, and this group of people took an interest in baseball. Now, it so happened that season there was a baseball player who was having a great season. Every time he played a game, he got a hit. He got a single, a double, a triple, or a home run. At least one of those hits in a baseball game. Now, if you go back, and a few of you will know this, the record for consecutive games in which a ball player has gotten hits was set in 1941 by Joe DiMaggio. He had 56 straight games in which he got a hit. And now the closest anyone's ever come to that was Pete Rose, and I think one other ball player got 44 games in a row with hits. But Joe DiMaggio has got 56. No one's ever come close. It's probably going to be, if there's a baseball record that's going to stand in our lifetime, it's going to be that one. All right, well, getting on with the story, this science fiction story. During this baseball season, there was a player who started getting close to Joe DiMaggio's hit record. When he got to 50 games, people got really excited. The whole country was paying attention to baseball. And these people, these aliens, wanted to see the baseball games, and so they were taken there to see the games, and it got real exciting. And sure enough, the ball player ties Joe DiMaggio's record, and everybody's going nuts. And now the next game, will he break Joe DiMaggio's record? Of course, the aliens are there, and he does. He breaks the record. And the aliens come out and they say, well, people ask, well, what do you think? He says, oh, this is fantastic, fantastic. We loved it. And then they were finally ready to admit who they were. They actually were humans. They were from the distant future. And they said, look, we're from your future. That's why we can't tell you anything else about ourselves, because we're going back. We just came back in time because we wanted to see 7 standard deviations. And that was the punchline in the story. They wanted to witness 7 standard deviations. All right, and that was what this guy's record apparently was, at least in the science fiction story. So anyway, you may not find that as amusing as I do, but I just thought that was a great punchline for that story. All right, but 7 standard deviations. Is there anything out there that's truly 7 standard deviations? Well, let me go on to that here in a minute. I'm going to halt the video, and we'll pick it up in a little bit. I don't want you to think that that you'll never see a standard deviation of, say, 7 or something even higher. Those things show up when we do statistics, but when they do, it leads us to doubt a particular conclusion about the data. It leads us to an alternative conclusion. So I'm going to have to wait a little bit before I can really explain that statement well and give you an example. But first I need to introduce what's called the standard score, or the z-score. So the standard score, which I like to call it the z-score, is z equal to x minus x bar divided by s. X minus x bar divided by s. So the way I like to introduce this is to the example of the IQ tests. Now, IQ tests have been given for, we'll say 100 years, something like that. Psychologists like to do that. I happen to think it's kind of overrated for measuring intelligence, but anyway, it is what it is. And for the IQ test, the mean is 100. It's actually set to be 100. And so by definition, the average IQ is always an IQ of 100. And the standard deviation is around 15. You know, I've seen slightly different numbers, but 15, close enough. Pretty good, estimate of the standard deviation. All right, so what is the z-score of 115? 115, if x is 115, then the z-score is 115 minus 100 divided by 15. Now, a score of 115 is 15 points above the mean. And if you divide by the standard deviation, that means that's one standard deviation. So you see the z-score is the standard score is a computation of the number of standard deviations that a particular number is from the mean. So 115 is one standard deviation above the mean. Okay. What about an IQ of 130? All right. You're probably thinking, well, that sounds like 2 standard deviations above the mean. And indeed it is. So for an IQ of 130, our standard score, the z-score, would be 130 minus 100 divided by 15. That would be 30 points above average. Divided by 15 would be 2. Would be 2. All right, now I want you to turn to a page in the back of your book. And let's see, it's page, I usually have it memorized, 650, I think. 649, page 649 in your book. And it's the right-hand side of the page here. It's called Tail Probabilities for Values of Z. This is the Z chart. Okay. Now, a z-score of 2, think of that as 2.00. 2.00. All right. Where would you find a z-score of 2.00 in the book? If you look down this column, the left-hand column, look for 2.0, and that's right about in the middle. And then, so 2.0 carries it to 1 decimal place. To go that second decimal place, we'll go to the 0.00 column, which is your first column. So go to 2.0, your first column is the area, or tail probability, I should say, the tail probability associated with a z-score of 2.00. And what number do you see? I've got 0.228. 0.228. So the tail probability means that if I go 2 standard deviations above the mean, the area on the tail side, in this case the right side, past 2, greater than 2, is 0.0228 or 2.28%. So that's what that tail probability means. So a z-score of 130 means there's a tail probability of 2.28%. That tells us that 2.28% of the population has an IQ higher than 130. That's what that means. Now if you were to calculate the z-score for an IQ of 70, which is rather low, the z-score would be 70 minus 100 over 15, which is minus 30 over 15. That would be minus 2.00. So a z-score can be negative, and a negative z-score just means that you're below the mean. You're below the mean rather than above the mean. And this is, one of the very few times in math where you can ignore a negative sign, because the textbook charts don't have negative z-scores.